Chemistry 20 right now and you're in the solutions unit, you might have come across some information on parts per million or parts per billion. It's just another way to show concentration when you have a very, very small amount of solute in your solution. So we know that you can dilute solutions and by adding lots and lots and lots of water. But if you did do this, then you'd have a very, very, very small amount of your solute, and that value would be very small. So instead of measuring the concentration as just grams per liter or moles per liter or anything like that, we're going to use your parts per million. So there is this extra information here just to remember. If you do have a solution and you're given volume, 1 milliliter will equal 1 gram. So we can just replace the units if needed. And then because this is a weight by weight ratio, we want to have our units in grams divided by our units in grams. So that again would matter if you're given volume, where we can just make a bit of a conversion. So the definition of parts per million is your mass of the solute in grams divided by your mass of the solution in grams. So you do that first and then multiply it by 10 to the power 6. So I will show you an easier way to calculate this if you're struggling with the math part when we get to the end. But these questions, I think, are not that bad. What makes it a bit more challenging is all the converting you need to do. So in this example, we have a bottle of water and it's told that you have 0.48 milligrams of the sodium ion per 250 milliliters of water. And then what is that concentration in parts per million? So in this case, you are solving for parts per million. You have the solute, but your solute is in grams. So you will have to make a conversion turning your milligrams into grams. So I'm just going to use unit analysis here, and there's 1,000 milligrams in 1 gram. So that's our first part. We'll take that 0.48 and times it by 1 over 1,000. When you do that, you'll get the value of your solute, so 0.00048 grams, and then you'll divide it by your solution. And your solution here is 250 milliliters, but this is when we can use that information, that 250 milliliters will equal the same in grams. So this went away here, but that's okay. We have that, we fill that part in, and then you have times 10 to the power of 6. So when you are solving for parts per million, put your fraction into your calculator first, and then multiply it by 10 to the exponent of 6. Once you do that, you should see that your answer is 1.92 parts per million. But I noticed as I was doing this that this value here has 2 sig digs. So if I was counting sig digs, it should actually be 1.9 parts per million because we always want to go to the least amount. Our next example is one where you're given parts per million and we're going to find the mass of solute. So in this case, you're given parts per million, so we have that. We want to know the mass of carbon dioxide, so we're solving for solute in a solution or the air altogether of 1.0 kilograms. So notice here we have one more conversion to make, and there are 1,000 grams in 1 kilogram, so we can just replace that bottom with 1,000. So let's do some replacing or substituting. We have 10,000 parts per million will equal, we don't know the numerator, so let's just call it X, over 1,000, making sure our units are in grams. This is all about times 10 to the power of 6. So our first step before we can touch the fraction is to get rid of that 10 to the power of 6. So divide both sides by 10 to the power of 6. When you're putting this into your calculator, just make sure to keep this denominator in brackets. Now, if you get to this point, what you can recognize is that you have 2 fractions equaling each other with 1 unknown. So the really easy way to solve for this without isolating is to cross multiply, so 1,000 times 10,000, and then divide. So in your calculators, you would do your 10,000, and there we go, times 1,000, get your answer, and then divide by, make sure you put this in brackets, 10 to the power of 6. And if we do that correctly, you should see your solute is 10 grams. This is only if you want to do cross multiplying and dividing. You could also just figure out the left-hand side, multiply both sides by 1,000. That's still the same thing. Okay, so this question gets a little bit harder, again, because of the units. So we have a 1.3 kilogram fish was found to have a very, very small amount of lead, 4.81 micrograms. And then we want to know what that value is in concentration, parts per million. So notice our first couple conversions here, 4.18 micrograms. We're going to multiply this by 1 gram over a million. So that is 6 zeros. Now, if you didn't know that, that conversion is in your data booklet. You just would have to look it up and make sure you know how to use it correctly. So we would have that 4.81, and then you'd want to times it by 1 over a million. So make sure you have those 6 zeros, and you're going to get a very small number, 0.00000. So I should have 5 zeros there, 481. Then we want to divide this by our solution in grams. So this one we have kilograms. We can multiply that by 1,000 to get to grams. I don't know why this keeps moving away from me. So if you did that, you would have 13,000 in the denominator. And then lastly, once you had that value, you multiply it by 10 to the power 6. So we go ahead and put that into your calculator. Again, do this part first, the fraction, times it by 10 to the exponent 6, and you should get this answer, 0.0037 parts per million, ppm. Okay. Our next one, we have a similar one where you're given parts per million first, right? So you know that because of the unit. And we want to figure out the mass of solute, so the numerator, in 170 grams. So this is nice. We don't have any extra converting. We can just go ahead and fill in numbers. So 15,000 parts per million will equal X over 170 grams times 10 to the power of 6. So again, before we can do anything with that fraction, we have to isolate it. So divide both sides by 10 to the power of 6. Okay, so this part will go away. Then we have that fraction where both two fractions equal with one unknown. So the fastest way, in my opinion, to do this is cross multiply and then divide. If you don't like that, figure out what the left side equals and then multiply both sides by 170. Again, if you do this correctly, you should get 0.225 grams. And if you're not getting that, double check that you're putting that denominator in brackets. Okay, so last one here, we have again given parts per million. This one's a little bit different because instead of finding solute, you're finding solution. So you're told you have 1 gram of gold and you want to figure out how much water that's in. So if you had 4 times 10 to the negative 6 parts per million will equal 1 gram of your gold over an unknown, and then it's still times 10 to the power of 6. So just like the other ones, we have to isolate this fraction, so divide both sides by 10 to the power of 6. And this part goes away. And then again, this is why I think this part's easier if you cross multiply and divide. Finding this unknown is a little bit harder. Oh, that's annoying. And this is just 1. Finding the denominator as an unknown is a little bit harder because you'd have to get your left-hand side, multiply the x up, and then isolate the x once again. If you keep it like these fractions, you can just cross multiply and then divide. So you would go 10 to the power of 6 times 1 divided by 4 times 10 to the negative 6. Now, because we're multiplying and dividing, just make sure you have those brackets in your calculator. And when you do that, so I'm just going to do that quickly in my phone here, or calculator. So you'll have 1 times 10 to the power of 6, and then divided by, again, make sure you have brackets here, 4 times 10 to the negative 6. I did something wrong. So we have 10 to the power of 6 divided by 4 times 10 to the negative 6. There we go. So here you're getting 2.5 times 10 to the power of 11, but this value is in grams. So notice the difference here. We have grams, and in your answer you have liters. So we can remember that 1 milliliter equals 1 gram. So we can easily just take this gram out and replace it with milliliters, again, because 1 milliliter equals 1 gram. So we can replace those units. Then what we can do is remember that there are, in 1 liter, there's 1,000 milliliters. So we get that value that we're given, and then we're going to multiply it by 1/1000. Oh, one more. And if you do that, you'll have that answer that you're looking for there, 2.5 times 10 to the power of 8 liters. Notice that this value should have been an exponent. So we have everything we need. We just had to make that one extra conversion because that answer wasn't given in milliliters, it was given in liters. So I hope you found this helpful. If you did, please subscribe. If there's any other video I can help you with or topic, just leave me a comment. And if you are in Chemistry 30 or Calculus, I do have a website for that. So take a look at the link in the description. Thanks for watching.